Alright guys, here's the deal. We lost 20 games in a row now. It's time for a change. Today, you'll be reevaluating your skills. You'll get one swing to hit a ball 300 feet. If you don't do it, you're off the team.
But coach, we paid good money to be on this team.
Doesn't matter. I'm the coach! You do what I say! Now get out there and play ball! Never seen such a bad swing in my life! You're cut! Do you know how to play baseball? You're cut!
Coach, I hit it. Coach, are you impressed?
You hit 3 feet! I said 300! You're cut! Finally, a decent hit. I think I need to get my tape measure for my car. I'll be right back. Shoot, I forgot my tape measure. What are we gonna do now?
I know what to do. We can use calculus.
Wow, are we seriously going to use calculus in the real world?
I always have my calculus notes on me. I remember this. We can take the integral from the time the ball is hit to the time the ball lands of the absolute value of the velocity function to find the total distance traveled. Okay, the ball went 329.291 feet.
Well, how in the world did you figure that out?
All I had to do was find the horizontal distance traveled by the ball by taking the integral from time 0 to the time the ball lands. To find when the ball lands, I first needed to find the initial vertical velocity to plug into the position equation. Since the velocity on the radar gun was 70 miles per hour converted to 102.667 feet per second, we can use a vector or a quantity that has both magnitude and direction to find the initial vertical and horizontal velocity that we need. The total velocity is represented by the hypotenuse of the triangle, and the legs represent the horizontal and vertical components. Assuming the launch angle of the ball was 45 degrees, we can also assume that each leg are the same length. Therefore, we can use the Pythagorean theorem, which states a squared plus b squared equals c squared. In our scenario, the legs are the same, meaning the equation is 2a squared equals 102.667 squared. Solving for a gives you 72.597, meaning the initial horizontal and vertical velocities are both 72.597 feet per second. Now we can plug in the initial vertical velocity to the position equation of a projectile, s of t equals negative 16t squared plus an initial vertical velocity plus original height. So the equation is s of t equals a negative 16t squared plus 72.597 t. This represents the height of the ball at any time, so using a calculator we can find when the height is equal to 0. This occurs at time 0 and 4.537, meaning the ball lands after 4.537 seconds. Since the horizontal velocity of a projectile is constant, we can take the integral from 0 to 4.537 of 72.597, which gives us a distance of 329.291 feet.
Wow, that was actually interesting. I bet you can't find the time when the ball reaches the maximum height.
That's easy. All you have to do is derive the position function using the power rule to find the vertical velocity of the function and see where the graph changes from positive to negative on the calculator. Deriving s of t equals negative 16t squared plus 72.597 gives you v of t equals negative 32t plus 72.597. The graph changes from positive to negative at 2.269, meaning the ball reaches maximum height at 2.269 seconds.
But how high did it go?
Just plug in 2.269 into the position function to get s of 2.269 equal to 82.348 feet.
But what about the velocity at, let's say, 2 seconds?
The velocity at time 2, we'll need to use another vector with horizontal velocity of 72.597 feet per second and vertical velocity of v of 2. Plugging in 2 to the velocity function gives you 8.597 feet per second. Now to find the total velocity of the ball, just use the Pythagorean theorem to find the hypotenuse, which results to 73.104 feet per second.
So I guess there are applications of calculus in the real world. Maybe I should have paid more attention in class.
So you hit the ball 300 feet. Big deal. You're nothing special, kid. But you're the only one who made the team. So there you have it.